Thermal electric current is understood as the release of thermal energy during the passage of electric current through a conductor. When current passes through a conductor, the free electrons that form the current collide with atoms and ions of conductor, heating it. The amount of released heat can be determined by Joule-Lenz law, which is formulated as follows: the amount of released heat in the conductor is equal to the product of the square of the current, of the resistance, and of the time of the passage of current through a conductor. Taking the current in amperes, resistance in ohms, and time in seconds, we get the amount of heat in joules. And given that the current strength for resistance is voltage, voltage for current is the power. As a result, it turns out that the amount of heat released in this case is the amount of electrical energy transferred to the conductor during the passage of current through it. That means that electrical energy is converted into thermal energy.
This phenomenon was discovered in 1800 by French scientist Antoine Fourcroy. 41 years later, English physicist Joule became interested in thermal effect of an electric current, and a year later Russian scientist Emil Lenz too. They found that the amount of heat allocated by a conductor with current is equal to the multiplication of current strength, the resistance of the conductor, and time it takes to go through it. Interesting fact: Benjamin Franklin was involved in the study of electricity. Many people know him as a great historical person who made great contribution to the formation of United States as independent states, but he also invented a lightning rod.
Any measurement result cannot be absolutely accurate and necessarily contains some error. The smaller this error, the more accurate the result itself. For example, the same absolute error of 1 mm for a segment whose length is 1 mm is very large, and for a segment with a length of 1 meter it is quite good. The last digits of the number are considered absolute errors. The accuracy of a number is determined by its relative error. Relative error is the ratio of the absolute error to the number itself. In our experiment, we need a scale with a relative error, which is equal to 1 gram. But we also take into account that ice can melt from air temperature. We will take this into account in the experiment.
On this plate we will put ice, which we will melt with the soldering iron. On this plate we will leave the ice to melt. Knowing the mass of ice and the power of the soldering iron, we can find time for which the ice will melt in theory. The time will be approximately 85 seconds, but since the ice isn't in isolation, there will be less melting at present. we subtract the mass of the melted ice from the initial mass of ice. We get mass of molten ice.
The life of a modern person cannot be imagined without electricity. Many ideas and inventions couldn't be realized without electricity at that time. Discovery of electric current made a revolution in the worldview of all humanity. Agriculture, science, medicine, radio and television, internet, and streetlight and the others, street communications. It's a small part of the use the electricity.